So our objective is to use 2 or more methods to prove triangles congruent. For our warm-ups, tell whether the pair of triangles are congruent or not and why. So, do we think our 2 triangles are congruent on letter A?
Yes.
Why? Good. Side, side, side. Thank you. Side, side, side would work for letter A. Yes. Side, side, side. We can prove that last side down the middle congruent to itself by the reflexive property. What about letter B?
Yes.
I would say it is a yes. Somebody said it. It is not side angle side. It is HO. Side angle side would not work here because the included angle is not marked.
That's a real thing?
Yep, we learned it in our notes. Hypotenuse leg.
Wow.
Questions about number 1? Okay. Number 2, if angle 1 is supplementary to angle 2 and angle 1 is supplementary to angle 3, what do you know about angles 2 and 3? They're congruent. Does anybody remember the name of that theorem?
Transitive. Oops. I don't know. Substitution?
Nope.
Radii.
We don't have a circle, so I don't know why we would talk about radii. It is a theorem. The supplementary angles congruence theorem, or the congruent supplements theorem. Congruent supplements theorem. We used that back when we did those puzzle proofs. Remember when you had your options and you had to figure out which ones went where? It's been a while since we've seen the congruent supplements theorem. But it's coming back today. Questions before we move on from this slide? Okay, on we go. Straight into one of our congruence postulates. If you had to guess, based on the name of it, ASA, what do you think this one involves?
Angle side angle.
Angle side angle. If 2 angles and an included side of one triangle are congruent to 2 angles and an included side of a second triangle, then the 2 triangles are congruent. Okay? So, if we're looking at this, we're marking our triangles. We need, first of all, 2 pairs of congruent angles. So, if I were to mark those 2 angles congruent and these 2 angles congruent. The included side is going to be the side that's in between those angles. So included side has to fall in between those 2 angles. And it has to happen that way on both of them. Questions about what angle side angle looks like? Can't be any of the other sides. There's only one included side. Are we ready for the next one? This one still involves 2 angles and a side, but how would we say this one? Angle, angle, side. So the order is important. If 2 angles and an unincluded side of one triangle are congruent to 2 angles and the corresponding non-included side of a second triangle, then the 2 triangles are congruent. Okay, so this one, again, we would have 2 pairs of angles. Are congruent. And then we need a pair of sides that's not included. But we have to be careful. So what I mean by that is that if I were to mark this bottom side from my first triangle, that's the side that is next to the one with one arc mark, or you could think about it as the one across from the one with two arc marks. So I have to make sure I use the corresponding side from my other triangle. So is that going to be on the left, the top, or the right? The left. Now I could have used the one that was across from the single arc mark on both of them instead, and this still would have been angle, angle, side. You just have to make sure that your sides that you're using are corresponding to each other. Questions about the difference from angle, side, angle to angle, angle, side? Nothing? Warm, fuzzy feelings? None of those either? Okay. Well, on we go. Can the triangles be proven congruent with the information in the diagram? If so, state the postulate or theorem you would use. So, letter A. Do we have enough information here?
Yes.
What would you use?
No, you don't.
I agree with Caleb. No, you don't.
Yes,
So,
you do.
I do. So, we could say that we've got vertical angles. That's true. We could mark those if you want to. But did we learn an angle, angle, angle postulate? No. Do we know anything about any of those sides? No. They didn't tell us anything about them. They didn't mark them. They didn't say you have a midpoint. They didn't say you have a bisector. We don't know anything about the sides. We might think they look a certain way, but there's not enough information for us to know for sure. So that one we cannot do. What about letter B? Yes, anybody know which postulate or theorem we would use? So let's run down our list. Our list includes side, 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 side angle, side, hypotenuse leg, angle, side angle, and angle, angle, side. So this is our list of possibilities. If you're ever stuck on a triangle proof or a question like this, go down your list and eliminate anything that you can. What could we eliminate off this list right away? Okay, we don't have right triangles. Hypotenuse leg is out. What else? Side, side, side. We don't have anything about most of the sides, so that's out. What else would technically be out? Side angle, side. How many sides do we know about? One. The one down the middle is congruent to itself. That's the only one we know about. So we could eliminate the one that has two S's because we only have one. So that leaves us with angle, side, angle, and angle, angle, side. Which one is it? Angle, angle, side, because the side is not in between the angles. So if you ever get stuck, make a list of all the ones we've learned and start eliminating them until you can make a decision. What about letter C? Yes, why? Good. Side, side, side. That last side could be shown with the reflexive property. What about letter D? Yes, why? Angle, side, angle. Good. We've got one more pair of angles that are vertical. And so now the side is in between the angles. So angle, side, angle. The first thing we write down for a proof is our givens. So when I get to your proofs on your quiz, I better not see any blank ones. AB congruent to CD, and we know that angle A is congruent to angle D. given. So angle A congruent to angle D, I'm going to go ahead and mark that in my diagram. There's nothing really for me to do with that except show it. Same with AB congruent to CD. Mark it in the diagram. Now, on a problem like this, some people might be tempted to use the reflexive property. Is that going to get us anywhere? No. We did not learn a postulate or theorem that said angle side side, because we don't write bad words in geometry class. And we don't write bad words backwards either. So no side side angles, no angle side sides. Are we good with that?
I don't get it.
Okay. Then write out the acronym for angle side side on your paper and then erase it.
Oh.
All right, there we go. So, reflexive property is not getting us anywhere. But what did they tell us in our givens that we haven't used yet? Micah? Yeah, they gave us parallel lines. And if it helps, you could mark those lines parallel with your little triangles. So we have parallel lines and we've got a transversal that cuts through them. Remember yesterday before your quiz, I reminded you that anytime you have parallel lines with a transversal cutting them, it forms congruent angles. So we have a pair of congruent angles here that we need to be able to list out. And list why. Anybody see which angles should be congruent here? ABC, B, C, D. Good. So angle ABC is this little one up here. I'll give it 2 arcs. 2 arcs. And BCD is this little one down here. Also gets 2 arcs. Now we have to be able to give a reason for that. So think about what the relationship is between those angles. Good. Alternate interior angles are congruent. If you just put alternate interior angles, that's fine. We know they're congruent because we had parallel lines, and those are alternate interior angles. Questions about step 2?
No.
That's definitely the hardest part of this. Yes?
So then couldn't we do CB as congruent to CB and then do side, angle side? I mean, yeah.
You could, but you don't need to. If you did that, I wouldn't mark it wrong. You're just doing more work than you have to do. Because we can already prove these triangles congruent. How? Angle, side, angle. So if you were to add in CB congruent to CB at this point with the reflexive property and use side, angle, side, that's fine with me, but that is adding an extra step. We can already say triangle ABC is congruent to triangle DCB using angle, side, angle. Questions about our first proof of the day? 3 whole steps. Oh, step 2? Okay, so let me draw a similar diagram down at the bottom. If we have parallel lines cut by a transversal here. So this is similar to the diagram they gave us. I just chopped off the sides. Are we okay with that? Okay, similar diagram, took off the sides. If I were then to also extend what I have here and show these extensions, kind of, sort of, then we can see our parallel lines top and bottom, getting cut by a big transversal. So yesterday, before the quiz, I went through and I had labeled some of these angles. 1, 2, 3, 4, 5, 6, 7, 8, something like this, right? We've seen these types of diagrams before. And so we talked about our angle relationships with parallel lines, like corresponding, alternate interior, and alternate exterior. Anytime you have those angle relationships with parallel lines, you know the angles are congruent. So in this case, the ones that actually fell inside of my diagram here would be the ones only made with purple lines. So that would be angles 4 and 6. Those are alternate interior angles. On the inside of the parallel lines, different sides of the transversal. So therefore, we can say that they are congruent. Okay, so I understand it can be challenging to visualize your alternate interior angles when you don't have the full diagram we looked at before. They're cutting parts of it off, adding different parts in, but the same theorem applies. Other questions? Further questions? Okay. Next one. I think it's probably a little bit longer, but not much. Oh, yours doesn't look like this? Do you have this one on the back? Okay, so flip over to the back. I don't know why they're out of order. I'm assuming my next one will be your one that we just skipped over. All right, we start off with our givens. Angle 1 congruent to angle 4. CF bisects angle ACE. All of that is given to us. Now in this problem, it might be helpful to focus on what triangles you're trying to prove congruent, because they have lots and lots of triangles here. So we are looking at triangle CBF. So that's this one here off to the side, and angle CDF. So these are the ones we care about, these little ones up on the inside middle top part. So with that in mind, let's see what we can make happen here. We could mark angles 1 and 4 congruent if that helps you. That's not part of our triangles, but it could help us with angles 2 and 3. So I'll just open it up to all of you. Where would you go next?
Since CF then A, C, yeah.
So we could talk about that angle bisector. That is a good place to start. So we're told that CF bisects angle ACE. So that means if we're bisecting an angle, that two little angles ought to be congruent to each other. So let's start there. What are those two little angles that ought to be congruent? Which ones? BCF or ACF, however you want to call it. This one right up here, I'm going to call it BCF. And which other one? DCF, the other one over there.
Doesn't matter if you like call it CBF or whatever.
CB, yes, because CBF would be talking about angle 2. So you could call it FCB, ACF, FCA. We just have to make sure that C is the middle point when we're talking about them. So D. Okay, why did we know that those two angles were congruent? Definition of an angle bisector. If you just put bisector, that's fine. Angle bisector is more accurate. All right, so that goes through one of our givens. That gives us some information. What else? Majay, what do you think?
Could we do angles 1 and 2 are supplementary?
Yep, how do we know that?
Assume
Not quite. So there are two ideas at play here. 1 and 2 are supplementary, and I'm okay with going straight to that. What would we have assumed from the diagram before that? Nope. We can never assume supplementary from a diagram, but there is a relationship there that then leads us to it. Taylor?
Linear pair.
Linear pair. Now, if you want to include the assume from diagram step, you need to tell me 1 and 2 are a linear pair, 3 and 4 are a linear pair. So I'll include that for completeness' sake. Angle 1, angle 2 are a linear pair. I'm going to go ahead and do 3 and 4 on the same step because 3 and 4 are also a linear pair, and that is something that we can assume from the diagram. Now, because we know they're linear pairs, then we can go with what Majay said about knowing that they are supplementary. So angle 1, angle 2 are supplementary. Angle 3, angle 4 are supplementary. And how did we know that?
Definition of linear.
Good. Definition of a linear pair. Actually, I think that might be the linear pair postulate. I'm okay with either way. You gotta have linear pair in there somewhere. Because they were linear pairs, we knew they were supplementary. Now that we've said all that, what do you think we were trying to get from that? Angles 2 and 3 are congruent. Ooh, that's step 5. Angle 2 is congruent to angle 3. Why? Bless you. Talked about it in the warm-ups. The congruent supplements theorem. If they're supplementary to each other or two congruent angles, then they are congruent to each other. Okay, so we are getting awfully close. Our triangle is getting filled up here. So now we're at 3 arc marks. Hard to squeeze that in. But we still don't quite have enough to say our triangles are congruent. But this last step should be the most obvious one to us. CF is congruent to CF. Why? The reflexive property. Ooh. I'm going to run myself out of space here. CF congruent to CF. Reason being reflexive property. And then my last step, which I'm going to have to write kind of sideways here. So then my last step would be what? The prove statement. Triangle CBF is congruent to triangle CDFY. Angle, side. Now, I'll admit that proof was a little more involved. Not quite as fun as the first one. Questions, concerns about that one? Okay, we've got one more. Hopefully, nope, it's not in my slideshow, so I'm going to have to add it.
Is one like that going to be on the quiz?
It's possible. Okay, let's put up that last one. It's going to take me a moment to get my diagram up there. So So you guys could start thinking about what your givens are telling you while I get this set up here for myself. Okay, they gave us quite a bit of information, which in my opinion is always nice. We got a lot to work with here. All of that was given to us. So things like AC congruent to DF, I would just mark right away. Angle C congruent to angle F, mark that. But now we have to deal with those other statements. What are those other statements telling me, Caitlin?
I have a question.
Oh, sure, question.
Did you say that they're right triangles?
Not yet. Not yet. We got to deal with the perpendicular lines first. Okay. But yes, we would be headed there in a sense. I don't know that in this proof we necessarily need to say we have right triangles at any point because we are not going to get set up to use hypotenuse leg. Does that make sense? Okay, the right angles will be important. So we've been dancing around it. What do those perpendicular lines tell us? Which angles are right angles? Good. Angle B is a right angle. Might as well also say angle E is a right angle. Our reason for both of those would be good. Definition of perpendicular lines. Perpendicular lines give us right angles. So if we know that they are right angles, what else do we know about them? They're congruent to each other. Angle B is congruent to angle E. Why is that? Good. All right angles are congruent. You could just say all right angles congruent. I think we might have titled it right angle congruence theorem. Something along those lines. You got to tell me right angles are congruent. If you were to take it as far as saying they both have a 90-degree measure and that's why they're congruent, you could go there. You're just adding more steps. Questions so far? So we could either mark these with right angle boxes or congruent marks. Now what? We can prove these triangles congruent. So which way did they list them out? A, B, C, and D, E, F. Triangle ABC is congruent to triangle D, E, F because angle, side.
Do you use hypotenuse leg too?
We could not use hypotenuse leg here. Why not? We don't have a leg. They gave us hypotenuses. They didn't give us any legs. So without any legs, we cannot use HL. Other questions? Anyone need more time on this proof?
No.
Before it disappears from the board? What? Nothing? No? Okay. Then back up to the homework, which of course I believe you have on your assignment guide.